Learning about nth roots and rational exponents. Finding the square root of a number is squaring a number and our inverse operations. I'll say that again. Finding the square root of a number and squaring a number are inverse operations. So roots and powers are inverse operations of each other. This expression over here would be read the nth root of 36. N is considered the index. This green part is the radical symbol, and then the expression or number under the radical is called our radicand. So you will hear me say index and radicand, so it's important to know what those words are. If our base or our radicand is positive, greater than 0, there's one unique positive and one unique negative root for even nth roots. Okay, if it's an odd root, there's only one positive answer. For a negative radicand, the even root of a negative number is not real, but you can take an odd root of a negative number and get a real answer. And then if it's your base or your radicand is 0, there will be one real answer. So the nth root of 0 is always 0. To be in simplified form, you cannot have a fraction radicand, and you can not have radicals in the denominator of a fraction. All right, so for example 1, to simplify the square root of 25x to the 4th, square root would be what times itself equals 25, and then for x to the 4th, what times itself equals x to the 4th. So because 5 squared equals 25, the square root of 25 is 5, and because x squared equals x to the 4th, the square root of x to the 4th is x squared. So when we look over here, you might just notice, okay, for the 4th power, the square root was x squared. 4 divided by 2 is 2. You can follow that rule every time for square root. So if you have an exponent, the power is 12 here, the square root will be to the 6th power. So notice the base, y squared plus 7, is grouped together. All of that is the base, and so we're just dividing the exponent by 2. When we're looking at third root, so we're asking ourselves what times itself equals 343? What times itself 3 times? Okay, so notice these powers here. 18 is divisible by 3, 6 is also divisible by 3. So 343 is 7 cubed. We could write a to the 18th as a to the 6th cubed, and then we could write b to the 6th as b squared cubed, and then the cube root and cube power cancel each other out. So that simplifies to 7, a to the 6th, b squared. Here we have the square root of a negative. So our index here is an understood 2, which is an even number. So the square root of a negative is not real. So we can think of it as square root of negative 1 is I. And then 17 times itself equals 289. And then for our even powers here, we divide the exponents by 2 to get the square root. So in a fourth root, we're thinking what times itself 4 times equals 81, and that would be 3. And then the fourth root of x to the 4th, those cancel each other out. This is 3 absolute value of x here. For this rule, when you find an even root of an even power and the result is odd, so the result is x to the 1st and 1 is odd, you must use absolute value of the result to ensure that the answer is non-negative. All right, and then for part B, I would just type into my calculator. If you don't know what number times itself 8 times equals 256, you can kind of guess and check, but it is 2. And then for taking the 8th root of a power of 24, we just take 24 divided by 8, and that gives us 3. Rational exponent, so that's when we have a fraction. If we had b to the 1 over n, that's the same as the nth root. Okay, so for example, 125 to the 1/3 power is the same as the third root of 125. Negative 49 to the 1/2 power is the same as square root of negative 49, which would be 7i. You could have a numerator other than 1 in your rational exponent. So for example, if we have 125 to the 2/3 power, that means the bottom number is still the index of your radical, and then the top number would be the power. So cube root of 125 squared. And cube root of 125 is 5, so 5 squared is 25. So this example here, if we had negative 49 to the 3/2 power, the half power means square root, and then the 3 means the power. So that would be 7i cubed, which is negative 343i. An expression with rational exponents is in simplest form when all of the following conditions are met. It has no negative exponents. It has no exponents that are not positive integers in the denominator. So this is similar to, you cannot have a radical in the denominator, you cannot have a integer exponent, or you cannot have a non-positive integer exponent. And it's not a complex fraction, and the index and any remaining radical is the least number possible. Okay, so to write this expression, x to the 4/3 in radical form, the bottom number will be the index of our radical, so this would be 3rd root of x to the 4th power. And then to write from radical to exponential form, this becomes x to the 2/5. So exponent is the top number in that fraction, the index will be the bottom number. The expression c times the quantity 1 plus r quantity to the t can be used to estimate the future cost of an item due to inflation, where c represents the current cost of the item. R represents the annual rate of inflation, and t represents the time in years. Write the expression in radical form for the future cost of an item 3 months from now if the annual rate of inflation is 4.7%. So remember, t is in years, and then they give us a time of 3 months. 3 months is 1/4 of a year. So we can put 1/4 in place of t. And 4.7 in decimal form is 0.047. So you just divide by 100, that converts it to a decimal. So we can simplify what's in parentheses here by adding 1 plus 0.047. And then the directions say write it in radical form. So 1/4 power would be the same as the 4th root. Now that 1/4 power only applies to 1 plus r, it doesn't apply to c. So we don't have c under the radical. To evaluate this expression, we got 32 to the negative 2/5. So negative exponents mean to divide by that number, that base 2/5 times. So I'm going to rewrite that in radical notation. So 2 over 5 as our exponent. 5 is the index, so we're saying 5th root of 32, and we square that. The 5th root of 32 is what number times itself 5 times equals 32, and that would be 2. And then we square that. 2 squared is 4, so our final answer is 1/4. When we're multiplying powers with the same base, we're going to keep the base and add the exponent. So I'm adding 2/3 plus 1/6, which gives us x to the 5/6. We have got a negative exponent here, so that would be 1 over y to the 2/3. And we can't have a fraction exponent in the denominator. So we want this exponent to be 1. So if I'm at 2/3, I'd have to add 1/3 to make it 3/3, or 1. So I'm going to multiply numerator and denominator by y to the 1/3. When I do that, in the numerator I get y to the 1/3, in the denominator we get y to the 1st. And then in the denominator, on part C, adding our exponents together, we would get z to the 5/12, which is positive number, so that's in simplified form. Thank you for watching.